Hi there, here's another lesson on Newton's second law. Newton's second law is F equals ma, and we saw F equals ma last time. And what I want to do today is build on F equals ma, because sometimes we get questions which have more than one force. So here's a little starter for you. I've written SOHCAHTOA on it already, so just be aware that's what you've got to use. You've got to use SOHCAHTOA. There's the answers, and you've got to use SOHCAHTOA to find the d value in each question. It's the same each time. So I say SOHCAHTOA, actually, it's actually Pythagoras. So use Pythagoras, not SOHCAHTOA. So we've got Newton's laws. Newton's second law says F equals ma. That's forces linked mass and acceleration. Sometimes we get more than one force, and when we do, we call it a resultant force. Basically, they either add together, or maybe if they go in different directions, they subtract from each other. And then it really isn't that hard to suss. I mean, just point out that's what I mean by acting in the same line. They don't have to go the same way. It can go one to the left, one to the right, or one up, one down. Here is obviously to not act in the same line. We'll see some of those later. So very quickly, you can see these in action. I'll put the answers up, but you can quickly just do these yourselves. If I've got a force here of 3 newtons to the left and 5 to the right, it won't surprise you. Overall, it's 2 to the right. And I'll just put those answers up, and you can see those, pause them, and make sure you understand why. So we then are going on to look at this in more detail. Just a little note to yourself, constant speed here, it says is, let's make sure my pen works, constant speed here is the same thing as saying there's no acceleration, which means there's forces are in equilibrium. This is the word that means nothing is happening in terms of the forces. And basically forces left equals forces right. And I've got a question like this. You can read it, but basically we've got a box sat on the floor, and we've got 2 little kiddies trying to move it. Now, I'm trying to remember which way around. You've got one who pulls the handle to the left with a force of 20. And this is acting obviously on the floor. And we've got another force applied by the other child on the other side, which is 25 newtons. And they still can't move this box. And the reason why, of course, is there's a big frictional force acting down here, and this frictional force is stopping it moving. Now, bear in mind, frictional force is a funny thing. The frictional force that actually is acting changes according to what kind of force you push on it. So if I push something with a little force, it won't move, and the friction will kind of equal what I give it. So if I push with 10 newtons, it will give me 10 newtons back, so it doesn't move. I can't give it more, or else it will start moving. So it's always in equilibrium. If I give it a 20 newton force, it will push back with 20 newtons. It won't move. And here I'm pushing with 45 newtons by these 2 students, and the question says, what's the friction? Well, the friction is just 45 newtons. That's all they could muster. It didn't move, so that friction must be 45. If I was to push a bit more, perhaps this is a bigger force, then the friction would be a bigger force. Now there comes a point at which friction can't get any bigger, and that's when the box would start to slide, and that's called limiting friction. But for this question, it's 45 newtons, and interestingly, if I push to the left, the friction must be pushing to the right to counteract that. So friction 45 newtons to the right. Sometimes we get pictures like this. Just bear this in mind. In these questions then we're going to be asking what direction is it going in, what's the resultant force, what's the magnitude of that force. So typical question. So here's one with just 2 forces. Now first of all, I personally don't like writing them as I's and J's, but if I want to find that resultant force, all I do is I go, well, first force is 5 across and 7 up, and the second force that goes straight across, so I'm going to write that as a vector still, 6 naught. And just using vector notation, you can see 5 and 6 is 11, and 7 and 0 is 7. So really what this is saying is, and I'll just draw the picture slightly differently. I've got the first one which goes 6 straight across, 6 naught. And I've got the second one. Notice I'm going to draw this from here. So there's my second force, and that's 5 across 7 up. And the resultant is the kind of triangle finish, the line that finishes the triangle. And you'll notice that's my resultant then. If I go from here to here and then from here to here, it's the same as going boom, all the way straight there. So this R is saying it's 11 across and 7 up. Let's just draw that. So my R is actually going, despite all the things I was trying to do with this picture, the result of that is it went 11 across and 7 up. And that's what it says here. Now I get asked several things. That's what my resulting force is. Sometimes I'm asked for the magnitude, which will write like this. You'll remember this, we've seen this before. You square both numbers, you add them together, and you square root the answer. So 11 squared plus 7 squared, I've got 170. And when I find the square root of that, it must be about 13.0. So I'll just write that down. And the other thing you're asked to do is the direction, usually to what's called the positive horizontal. Now that's this line here. So you can see it's just that angle there. So I'll write this. Theta is always, using SOHCAHTOA, 7 over 11, the opposite over the adjacent. So always use tangent when you're finding these. Is the inverse tan of 7 divided by 11. I've got 32.5 degrees. Okay, that's what we've got to do. And 13.0, 32.5. And just to describe it, it's above the axis. So you can call it above the positive horizontal. Here's a one with 3. So exactly the same trick. You add the vectors together, the vector forces together. First one goes 3 to the left and nothing up. You always plus. The second one goes 6 across and 8 up. And the last one I'm writing down goes 0 across and 14 down. I just scan across that quickly. I get 3 across the top and minus 6 down here. Now again, draw that. Now 3 still goes right. Interestingly, minus 6 means it goes down. So the resultant of these is this picture. Right angle triangle again. The angle to the positive horizontal is there. That's my angle. So theta is the inverse tan of 6 opposite divided by the adjacent 3. Theta equals inverse tan, that's 6 divided by 3 is 2, so I get 63.4 degrees. And the resultant, that's the other thing we want on this one, I haven't found it yet. Then is the square root of 6 squared plus 3 squared. That's the square root of 36 plus 9, which is root 45. And if I do the square root of 45, according to me, it is 6.71. You get the idea. You do need to go to do these questions. Okay, let's move on. I've got one final one here. So if I just do it again, R equals, first one is minus 10 naught plus 0.6 plus 3 minus 5. Add them all together, I get minus 7 and 1. I'll just be a bit careful, because I reckon minus 7 from my start point goes 7 left. So that's 7 left. And still 1 up. So there's my R. The reason why I've done this, because this is my positive horizontal. So when it comes to find my angle, I actually want this angle. Let's do that straight away. The way I do it, of course, is I find this one. Theta is the inverse tan of 1 divided by 7. Can't imagine that's very big. Just looking at the pictures, it doesn't look very big. And I get 8.13 degrees. And of course, this is the angle I want. So the angle is, and we do that by 180 minus the 8. Well, I might as well call that 8 degrees, because when I round it to 3 6 figures, it's 172. Don't forget, you always have to find the R on these. So the R is the square root of 7 squared plus 1 squared. And I think that's 7.07 from memory. Yes, it is. Shows you how often I do these. 172 degrees. So anyway, next question. We've got 2 guys pushing a piano, it says. When they push this piano, here's my picture. So I've got someone pushing with, I don't know why I put it over. Let's go this way. We've got someone pushing with 200, and we've got someone pushing with 240. And it says there's a frictional force. Oh, the frictional force acting against them is 380. So, okay then, so F equals MA. Now, here we've got three forces acting, so you can see 440 going one way, 380 going that way. Effectively, I've only got 60 left. 440 to the left, 380, I've got 60 left pushing this way. Equals the mass. What was the mass? The mass was 300 times A. So 60 divided by the 300 equals the A, which is 0.2 meters per second squared. And there's the answer. Fantastic. So a couple more like that where we're using F equals MA much more directly. So what are we doing on this one? We've got a 900 kilogram car, straight level track against a constant resisted force. So I'm going to say that's my resistance, my friction of 1300 newtons. And the acceleration, now this is the acceleration I've written here, A equals 3. And it must have a driving force, which I'll call dF. So of course F equals MA, that's no different. So I'm going to write, now here's the important thing, it's going to the right is in terms of the acceleration, so I've written dF first. And I then write minus the 1300 equals the mass, what was that, 900, times by the acceleration, the acceleration is 3. Now obviously this is 2,700. If I move the 1300 over, it becomes a plus. So you can clearly see the driving force on this car must be 4,000 newtons. Oops, slight extra Newton, 4,000 newtons. Another one, let's just see, we've got two children pulling a box in opposite directions now. Now, again, we do the same basic trick. Which way is it? It's going to go this way. This guy's pulling more. So if I do F equals MA, what's left over? Well, I'll just write 26.4 minus the 18.8 equals 8A. What's that? 1.2, I'm just doing this in my head, 7.6 newtons left over equals 8A. A equals 7.6 divided by 8. Yeah, I've done it right. 7.6 divided by 8. And I get 0.95 for that. Yeah, 0.95 meters per second squared. There it is. And then a third child comes along. He starts pushing, or pulling rather, with a force of F3. So it was going this way with an acceleration of 0.95. The third kid comes along and he must be pulling, I'm guessing, this way. That's my gut feeling. Because it's slowing down, that acceleration is now only 0.7. So let's just do this. Before we knew that it was 7.6 left over, so I'm tempted to write 7.6 was left over, and now we're losing a bit of that because the little kid's pulling back, and that equals MA, or put a different way, 7.6 minus the friction, the F3 rather, equals the 8, and now we've only got 0.7. So times that together, get 5.6. 7.6 minus F3. Move that way, that way. I reckon I get F3 equals 2 newtons. To the left as well. Yeah, my picture confirms that. And so now it's your turn. You've got some questions to do. There's no homework for this one. The homework comes after exercise 21C, which I'll put and do for tomorrow. So have a crack at this on the exercises, and email me or Miss Stanley if you have any issues. Okay, all the best. Thank you.